Okay, in this video, I go over the forecasting homework. In problems 6 and 7, we're given a data set of actual data, what really happened, and we're asked to forecast using moving average in problem 6 and exponential smoothing in problem 7. And in both of those, you need to evaluate what is best, which forecasting technique is best. And I want you to use the mean absolute percent error, not the mean squared error or the mean absolute deviation. So, for the first problem, you can forecast a moving average by taking the two most recent data points. You can copy that formula as far up as you want, except you need to have at least two data points to start, so you can copy that one up and forecast month 3, and if the moving average is equal to 3, you can't start until month 4. So these are the forecast. And then for exponential smoothing, I've set up from alpha equal to 0.1 to 0.9. And these, so the forecast, remember initialization, we always initialize to being the actual sale or the actual for the first time period. After that, you use the formula, which is it's a weight of alpha times the previous actual plus 1 minus alpha times the previous forecast. And if you notice the way that sets up, you will always get the same number twice. After that, you don't. And so now these become the forecast if you're using alpha equal to 0.1, 0.2, 0.3, and so forth. Once I've done this, I now go calculate my forecast accuracy. So down here, how I calculate a forecast accuracy is to first of all take the absolute value of the difference between the forecast and what really happened, the actual, divided by what really happened, and show that as a percent. So for anywhere I have a forecast and actual, I can get that number. So I have a forecast and actual there. I don't there, but I do here. These for all the exponential smoothing. I didn't use the very first one at all. And I didn't go to time period 16 because we don't have an actual. So these are all the percent errors, the absolute percent errors. And then I can calculate the average mate, by taking the average of what I have. And if you notice that I copied this formula over, I've got some blank cells. That's perfectly okay. Excel does not treat that as 0. It just ignores it when you use the average function. So when I look at this, it looks like the very best alpha is smaller the better. Kind of a lousy example, but it looks like a forecast of alpha smaller the better. I've got 0.1. I'm guessing that 0 is even better than that. Again, not a great problem, but that's what we have. You didn't have to do problem 9 so the next one we'll look at is 11. We're given data and you want to look at what the average increase is. Again, what we want to do is build a theoretical model and use that because the theoretical model is what we're going to use to predict the future. So we take the theoretical model and take the slope of the theoretical model. So the dotted line is what we think if we project this in the future. So the slope of that is a $1.77. Or I could have just used a formula just like that to calculate the slope given the y's and the x's. And that's the homework. Thanks.